Hello students, how are you all? Welcome back to Akshar IIT Foundation classes. So, 8th class, in the previously we have completed a very big chapter, that is atomic structure, right students? So, till today, in still last class, we were discussing about the atomic structure. It was a very big and vast chapter that we have completed in the last class, right? Today, we are going to start a new chapter. So, see students, here in our IIT Foundation, we are in IIT Foundation, and about the first term, before going to the periodic classification of elements, there was already a topic in the 7th class, okay, in IIT Foundation, right? So, here we start directly in the 8th class, we start from the arrangement of the elements in the periodic table, arrangement of the elements in the periodic table, from there we start. But to construct the periodic table, okay, to construct the periodic table, so here you see there is a periodic table, there is a periodic table, so, right. So, before coming to the, we are following that periodic table. So, before arranging this periodic table, so many scientists are tried to classify the elements, right. So, here basically the classification in a scientific way, it is started from the scientist called Dobereiner. Who was the scientist? Dobereiner. So, Dobereiner was the person who first tried to classify the elements, okay. So, you know that total we are having at present 118 elements, 118 elements. So, this one, it is difficult to remember the properties of all these elements to anyone. So, that is what the scientists tried to make it simple. How? By classifying the elements, right. So, in that process, the first classification was done by the Dobereiner. So, Dobereiner in the 1817, he classified the elements, and at that time the number of known elements were very, very less, and these elements he arranged into some groups. In every group he arranged 3 elements. How many elements? 3 elements, and these are called triads. Tri means what? 3. So, 3 elements like this. But later some new elements were discovered, so there was no place for the new elements in that period, in this classification. So, that is what it was proved as wrong, right. Then the next scientist Newland was another person who tried to classify the elements. At that time the number of elements were increased, so almost it has come to 56 elements, and he arranged the elements, but he arranged the elements not in the classified the elements not like in the groups, but he arranged all the elements in the increasing order of their atomic masses, Already we discussed atomic number, atomic mass in the previous classes, okay. So, based on the increasing order of their atomic masses, then he found that every 8th element has the similar properties that of the first element, okay. See, if the elements are arranged like this, in this the first element is what? See, yellow color, lithium. So, from here if I start 1, 2, 3, 4, 5, 6, 7, 8. So, 8th element is what? Sodium. So, whatever the properties in the lithium, the similar properties are repeating in the sodium. From here if you count 1, 2, 3, 4, 5, 6, 7, 8, okay. So, this is the 8th element. So, whatever the properties in the sodium, the similar properties are repeating in the potassium, right. So, now these all 3 having the similar properties. So, he said that like every 8th element has the similar properties that of the first element, okay. So, that was a Newland's concept, okay, Newland's concept of octaves, okay, but it was also failed. Then sorry, then another scientist called Mendeleev. Okay. Mendeleev was another scientist who proposed one law, and what he observed that the properties of the elements or the periodic function of their atomic masses means what? The properties of the elements or the periodic function of their means depends on their atomic masses. So, based on this he tried to classify the elements, okay. How? By constructing one periodic table, It is not that periodic table, just similar to this one, okay. So, similar to this one he tried to classify the elements by constructing one periodic table. And this periodic table was short, and but of course he arranged the elements, almost more elements arranged in this periodic table. But here also there were some drawbacks out there. Okay, we are not going to discuss about the drawback. Okay, so here also there were some drawbacks out there, and after that a new concept has come, that's called atomic number. Atomic number. Okay, Mendel's periodic table was based on what? Atomic masses. But the new concept was introduced, that's called atomic number. Now the modern periodic law proposed by Moseley, and Moseley what he said, Moseley, okay. Okay, Moseley was the scientist who proposed one new law which is called as a Moseley's periodic law, which is later called as a modern periodic law. So Moseley's periodic table, what it states is the properties of the elements, properties of the elements or the periodic function of their atomic numbers. Okay, this was proposed by the Moseley. So Moseley proposed that modern periodic law. So according to that periodic law, what it states is the properties of the elements or the periodic function of their atomic number. Means what? The properties of the elements depends on atomic number. The meaning is that, okay, the properties of the elements depends on the atomic number, right? Now based on this concept, one periodic table is prepared. That is called a modern periodic table. What is called a modern periodic table, and it is also called a long form of periodic table. What it's called? A long form of periodic table. Okay. So from here actually our lesson starts, right? So now let's go to the our actual lesson, that's called modern periodic table. So see students, here this is a modern periodic table. Can you see on the screen the modern periodic table? This is very long from here to there, no? So it's a very long periodic table. So here long sen in the meaning of long is here 18 vertical columns are there. How many vertical columns? 18 vertical columns. Can you check here? So 1, 2, so from here I'll check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 vertical columns are there. Okay. And how many horizontal rows are there? Horizontal rows are 7. So you can see a 1, 2, 3, 4, 5, 6, 7. Okay. Apart from this 7 horizontal rows, so here down you see 2 more series of elements also there. These are 2 more series of elements. Okay. So this is a long form of period. So periodic table of elements. So now we'll arrange the table like this. Right. Now the total periodic table is there. So this is called modern periodic table. I think you might have seen, okay, in your school, in your lab, chemistry lab, and your class. So these are about the periodic table, right? So you might have studied about the metals, non-metals. This is all you have studied, no? So these are all elements here only. Okay. So total as of now, there, okay, it is total 118 elements are there in the nature. How many? 118 elements as of now, okay, according to your textbook. So those 118 elements are arranged in this periodic table, How? In the increasing order of their atomic numbers. In the increasing order of their atomic numbers means what? Ascending order. Like 1, 2, 3, 4. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Like this, you can see 118. So total 118 elements are arranged in this periodic table. Clear? Now, so arrange the elements, okay. Then what is the use of this periodic table? Your question is that what is the use of this periodic table? So see students, here this is a very, very important, it's a very useful periodic table, because by seeing this element in this periodic table, you can say that whether it is a metal or non-metal, it's a solid or it's a liquid or it's a gas, or what are its physical properties, what are its chemical properties, how do they react with other elements. This all we can say just by seeing this periodic table. Okay. So, if you see here, except the hydrogen, so just to close the hydrogen, except the hydrogen, remaining all till here steps, you can see a step, okay, like this steps are there, okay, till here all are metals only. What are they? All are metals, right? Now, if you go this side, okay, this yellow color part, till yellow color part. So, yellow how it is there, you can see here, okay, till here, these all are the metals. And you can see here this green color one, okay. So, green color one are considered as metalloids. What they are? Metalloids, okay. And above the green, now here, whatever these all blue color, this all you can see, these all are non-metals. What are they? Non-metals. So, metals, metalloids, non-metals, okay. So, like this we can see the elements in the periodic table, right. And we can also come to know what are its physical and chemical properties, how do they react also, okay. So, okay, we will see these all things step by step, one by one. So, the total, the 118 elements are arranged in this periodic table. So, now if you see the arrangement, okay. So, as I told you that it consists of, okay, it consists of 18 vertical columns, 1, 2, 3, 4, and these vertical columns are called groups. What they are called? Groups. So, where should I write? Here I will write, okay. So, groups. Which are the groups? Vertical columns like this, coming down, showing down, these are the groups, right. And these horizontal columns, you can see here horizontal, okay, like this, like this. These are called periods. What they are called? Periods. Clear? So, periods and groups. Horizontal, like this, horizontal rows which are there, these are called as periods, and vertical columns which are there, they are called as groups. So, there are 7 periods. How many periods are there? 7 periods. And number of groups, how many? 18 groups are there. How many groups are there? 18 groups are there. So, in this elements are arranged. Okay. Apart from this one, there is one small table is there, in which 2 series of elements are there, which are called lanthanides and actinoids. What they are called? Lanthanides and actinoids. Okay. So, lanthanides and actinoids. So, you can see a lanthanide. So, color you can see this color, okay, this color is called lanthanide, and you can see this is like green color. So, they are called actinide, okay. So, these are the lanthanides and actinoids, clear. Now, let us see how the elements are arranged. Now, you know, but how the elements are arranged here, the first period, this is what first period, this is a first period. First period consists of only 2 elements. If you observe, you can see that there are only 2 elements. Yes or no? The only 2 elements. One is called hydrogen, second is called helium. Only 2 elements are there. Now, if you see the second and third, they consist of 8 elements each. How many elements? 8 elements each. Here 8 elements, right? Now, come to these 2, okay, they contains 18 elements each. How many elements? 18 elements each, right? Now, here these now at present, of course, this is completely filled, but if you see your textbook, so there are 32, okay, here 32 elements are there. How many elements are there? 32. Now, you can ask the question, sir, you said that only 18 vertical columns are there, but you are writing 32, okay. So, there are only 18 elements are there, 18 vertical columns are there, but you are writing 32, how come it is possible? Yes. So, students, here, if you see, here you see the number 55, cesium, right, and then you see 56, then you see here 72 is there. What is that? 72. So, here 57 to 71 are missing, right. So, 57 this is, and see here 57, 58, 59, 60, 61, 62, 60 up to 71, right. So, these elements are also a part of this period only, are also part of this period only. These are called lanthanides. These are called what? Lanthanoids. Lanthanoids are a part of sixth period. Okay. So here 18 plus here 14. So total number of elements comes to 32. So here 32. Same way here also. So here also will have only 18, but we are writing 32 here because here the last, this one, actinoids. Actinoids means what? So you can see 87, 88, now 103. So remaining 89 to 103, okay, should be placed here. Okay. So this 14 plus this 18, it comes to 32, right? So these are the arrangement of the elements in this periodic table. Like these elements are arranged in this periodic table. Clear? Now, so what these periods are called? The first period has only 2 elements, so that is called the shortest period. What is called? Shortest means what? Small period, only 2 elements. Now, second and third periods are called short periods. That is called the shortest period. And these two are called short periods because they contains 8 elements each. Then this fourth and fifth are called long periods. What they are called? Long periods because they contains 18 elements each. How many elements? 18 elements. Now the remaining two, last two, they are called longest periods. What they are called? Longest. Okay. So because they contain 32 elements. So this is the arrangement of the elements in this periodic table. Clear? Any doubt? So that's about the arrangement of the elements in the periodic table. A, this is called 2A, this is called 3A, this is called 4A, this is called 5A, this is called 6A, this is called 7A. Okay, so 7A. Now here you see, okay, in the middle we left 10. So here this is called the third B, fourth B, fifth B, sixth B, okay, seventh B, and here you can see these 3 are considered as eighth group, okay, eighth group, and here this is 1B, this is 2B, okay. So like this they are given the names, and this one, this is the last group is called zero group. What it is called as a zero group, okay. So like this elements are in the periodic table are classified into two types of blocks, like A block and B block. So here you see 1A, 2A, 3A, 4A, 5A, 6A, 7A, and here you can see the zero group. Here this is 2B, 3B, 4B, 5B, 6B, 7, 8, okay. Like this they are arranged into the classification the groups, okay. Now here, what the most important point in this you have to remember is that the elements in the vertical column, the elements in the same vertical column will have almost the same properties. Means what? For example, here if you see, except the hydrogen keep arrow, now remaining all lithium, sodium, potassium, rubidium, cesium, francium, all these have the similar properties, okay. So and here you see beryllium, magnesium, calcium, strontium, barium and radium, these also, okay, have the similar properties. Means the vertical column, in that one vertical column, whatever the elements are there, all will have almost the same properties. For example, anyone can read like this group, oxygen, sulfur, selenium, tellurium, polonium, okay, these are also, okay, having the similar properties. So that's what the elements present in the same vertical column are also called as a family. What they are called as a family. Generally, you know family. So family means what? A group of members, okay. In your family, who are there? Your mom, your dad, your grandparents, you, your sisters and siblings, means brothers and everything, all are there. So all are like similar type, okay. So here also all these elements, the elements present in the same vertical column will have the same properties. So that's what they are also called as a families. Instead of groups, they can also call as a families. So here if you see students here, except the hydrogen, the first group, remaining all are called as alkali metals. What they are called? Alkali metals, okay. And second group elements, beryllium, magnesium, calcium, these are called alkaline earth metals. What they are called? Alkaline earth metals. Alkali means what? Base. The meaning of what? Alkali, base. So, these are the strong bases forming metals. What they are? Strong bases forming metals. So, they are called alkali metals. These are alkaline earth metals. They are also bases forms, but they mostly they are available under the earth. So, that is what they are called as the alkaline earth metals. And then come to the, this is a boron family, there is a carbon family, there is a nitrogen family, which is also called as a nicogens. What they are called? Nicogens. And nicogens means what? Generally, the meaning of nicogens in the Greek language is suffocation. What it is? A suffocation. So, these compounds of this, like nitrogen can form the ammonia, like this compound, they can form the suffocation. So, that is what they are called as nicogens. And these are called chalcogens, oxygen family, or chalcogens, means what? Mineral forming. Minerals you might have studied in the social. Most of the metals, they do not available in their original state, but they will be available in the combined state. They are called as minerals. And these are called halogens. Halos means what? Oceans, seas, which are mostly available under the sea water. And here these are called as a zero group or inert gases or noble gases. Okay, students. So, these are classification. Once if you have a text book, this material, once open the page number, in the page number you can see the 74, there is a classification of groups, how the names are called, the alkali metals, alkaline metals, boron family, nitrogen family, like this all are given here. So, once go through, read this one, and with this we stop today, and in the next class we discuss about the classification of elements based on their electronic configuration and based on the blocks like SPDF blocks are there that we study. Okay. So, students, once if you have a time, read this one and observe the periodic table in the class and just try to understand. Okay. So, with this we stop, students. Bye. See you. Tata. Take care.